Hi, Rosa.
One. Maybe we should just start.
We ready to start?
I think we should start.
And then y'all see the actual thing or yours is they also play on Zoom, then everyone watch together.
No, it's actually it's a live.
Someone did that.
There's a I don't know whether the team for more people there, but I don't know who is there. But actually, some like holding the camera, it's like an actual camera rocket.
Oh,
That's
We'll show the live telecast at 9. Yeah. Okay, good morning, everyone. Can you hear me? Yeah.
Yes.
Thank you for joining us so early on a Sunday morning. Okay, for this online launch event. Okay, my name is Eng Keng. Okay, I'm an instructor at the Engineering Design and Innovation Center at NUS. Right. So today it marks a very significant milestone for us. Okay, because we are launching our second satellite, which is developed together by our staff and students. Okay. So this satellite, Galassia-2, it will be launched at 9:01 a.m. today, which is about half an hour later. Okay, so it'll be a live telecast. Okay, so before I go further, I'd like to invite our center director, Dr. Yan Su Cheng, to give us an address. Okay, over to you, Dr. Yan.
Thank you, Enkeng. Welcome, everybody. It's bright and early in the morning, so thank you so much for joining us. I think this is a very exciting event today. So we actually have with us Professor Goh Che-hyang and then Dr. Rosa, some of the instructors who were involved in this project. There were actually a lot of students who worked on this project. They were from both the Innovation and Design program at NUS. So this is a second major program that brings in students from a lot of different departments like electrical engineering, mechanical, chemical, biomedical, and so on. And then we also collaborated with students from the electrical and computer engineering department as well. So they all came together to kind of work on this, and took several years. But so Enkeng will tell you a little bit more about the sort of history of the program and so on. But this is sort of we're seeing kind of the payoff, right, for all the students who work over the years. So yeah, I think without further ado, I'll let Enkeng tell you a little bit more about the history of the program and what is on the payload for this satellite launch. The launch will occur around 9 o'clock, so we have a little bit of time to kind of give you a bit of background to sort of understand what to expect, right? So thank you again for coming and joining us. So over to you, Enkeng.
Okay, thank you, Dr. Yan. All right. So for the benefit of those who are not so familiar with our satellite program, okay, so while waiting for launch, I would like to give you a brief run through on what we have been doing, right, in our satellite program. So basically, the Galassia program was started by a group of very passionate educators in NUS, okay, when together with our students, okay, they built our first Galassia CubeSat, right, and which was launched in December 2015. Okay, shown here is a picture on the left. You can see our engineer, okay, assembling and installing the Galassia on the launch vehicle, and on the right you can see part of the launch vehicle where the Galassia-2 was mounted together with 5 other satellites. Okay, so if you want to know more about what are the other satellites, I think you can go and Google and find out more. But basically, do you know where in the picture on the right? Do you know where is Galassia-2? Just make a quick guess before I show you the answer. Right. Okay, basically it's here, right? Yeah, so this gives you a picture of the size of the launch vehicle with respect to our satellite. Okay, so basically Galassia-2, okay, before Galassia-2, okay, yeah, Galassia-1, okay, was a 2U CubeSat, okay? It's a U2 cube carrying 2 scientific payloads, okay? So for those who are not so familiar with the term 2U, right, okay? So 1U is actually a standard measurement, okay, for the size of CubeSats. Okay, 1U is equivalent to a dimension of 10 cm by 10 cm by 10 cm. Okay, so that's a standard CubeSat measurement. Okay, so this means that 2U is a measurement of 10 cm by 10 cm by 20 cm. Right. So so following the success of Galassia, okay, the team began to work on Galassia-2, okay, starting in around 2017, okay. So Galassia-2 is a 3U CubeSat, okay, with remote sensing capability for agriculture and environmental change. The payload use a multispectral camera, right? So shown here are some of the subsystems, okay, developed by the students and engineers, okay. For example, the electrical power system, right? The solar panel deployment system, okay. Of course, we have the mechanical structures, okay, right, to deploy, to hold the satellite together and to deploy the solar panel, okay. So these are some of the projects the student can do with us, right, if you join our satellite program, okay. Then shown here is another example of a project done by our final year student last year, okay. So basically, they developed a propulsion system for CubeSat using 3D printing technology. Okay, so when they begin a project, you can see on the left, okay, they started from the sketch, right, on the paper, right, and then they ended up with a real prototype, right, at the end of the project, right, which is shown on the right side. Okay. So shown here is our Galassia-2 team lead Eugene, okay, testing and working on the Galassia-2 before it was mounted on the launch vehicle. Okay, he'll share more with you about this on the story from lab to launch. Okay, later on. Okay, right. Here's another picture of Eugene with our project consultant, Mr. Zhen Ning. Okay, who also has another satellite to be launched today. Okay, on the right you can see the solar panel. Right, Eugene will share more with you later on. Okay, so at this point, I'd like to share more about our program in IDP, right? So if you come to IDP, you have a chance to take our satellite track program, which can be part of your satisfaction for a second major, right, in IDP, right? So at the same time, if you are an ECE student, you can also choose to specialize in the space technology. So both programs actually work hand in hand, right? But in IDP, we focus on multidisciplinary project. Okay, so students from different disciplines can come and work together. But for ECE, right, you gain more in-depth knowledge about certain specific areas, right, related to satellites. Okay, so okay, this is our 4 years program in IDP. Okay, so in every year we have some courses for you to take, okay, towards the fulfillment of IDP requirement. And then as shown in the red arrows, right, you can see some courses related to space technology. Right, starting from year 2, you can take a course in Introduction to Space System for you to have a more in-depth understanding about various terms and technology in space systems. Okay, so when you go to year 3, then you can do year-long projects, right, relating to satellites. Okay. Okay, one thing good about enrolling in the satellite program is that you have a chance to take part in competition. Okay, shown here are students who have won the grand award and the grand prize in the last 2 years. Okay, after they take our module in introduction to space system. Okay, so the case study, right, that they work on in the module can also be used, right, for participation, right, in the annual space challenge. Okay, so on the right, you can see the 3 students won a grand prize of $10,000, which is right, not bad, right? Okay, so going forward, right? Okay, so we have a plan for more regular CubeSat launches. Okay, every 2 to 3 years. Okay, and then you also have a chance to do a project to take part in the CanSat competition. Okay, organized by the American Astronomical Society. Okay, or the University Rover Challenge, which is organized by the Mars Society. Okay, so okay, we have about 15 minutes towards the launch. Okay, so I think I would like to invite 2 speakers who are key players, right, in the success of Galassia-2 development. Okay, the first speaker is Dr. Luosa. Okay, she used to be the Galassia-2 team lead. Okay, she's now in New Zealand. Okay, so Luosa, I hand over to you now. If you'd like to say a few words.
Thank you, Inkin. Hello, I'm Losha. As Inkin said, I used to be heavily involved in the space education and the Galaxy development. I left the NUS 2 years ago. Currently, I'm living in New Zealand, so you can see it's winter here. It's very cool. Thank you again for inviting me to join this event. I'm very excited to be here to see the launch together with you of our NUS second CubeSat, which was developed from the education program. Well, as described by Inkin, NUS has provided great resources for students to develop CubeSat to gain hands-on experience. And actually, the education track, space education track provided by EDIC is one of the few undergraduate space education in the world. So I was very proud. I'm very proud to be part of it. And today, I can see actually since the beginning of the event, I have been searching the names in the Zoom. So I have seen many of the old faces. So I see my mentors, Pablo, Dr. Go here. Nice to see you again here. I see Eugene, Johannes, Renhan, not sure about the whole run here. They are our passionate engineers working on the project. I see some of our former students, Junan. Nice to see you guys. I may miss some of the names here because I'm not good at searching the name at the Zoom sessions. I want to say that I feel very lucky that I work with you in this project. And let's say I look forward to the success of the CubeSat launch and operations. And I look forward to seeing more CubeSat, which are developed from our education program in the future. Thank you very much. Thank you.
Okay, thank you, Losa. Okay, now we'll invite Eugene E, who is the current Galassia-2 team lead. Okay, he will tell us more about how he brings the Galassia-2 from lab to launch.
Okay, hi guys. Good morning. Really nice to see all the old faces, the old names, and then everybody just coming together to witness this launch. So I'm just going to quickly bring you guys through what actually Galassia-2 is, what is found inside the satellite, and how we brought it from our clean room in the Satellite Technology and Research Center all the way to the launch site to where we are today. Yeah, so in case you are wondering, what goes inside Galassia, right? Galassia is actually flying a multi-spectral camera payload as its main payload, together with some S-band transmitters to facilitate Earth observation. So this multi-spectral payload, right, is taking images in red, green, red edge, and near infrared bands, and it's quite a nice set of data to do agricultural remote sensing. So the rest of the satellite consists of the typical satellite bus components such as power, communication, comms, and attitude control that will help us achieve this mission. So after the mission was conceptualized, we actually did a lot of development and testing for our in-house built subsystems, and eventually, right, we were able to make the flight models. So these flight models, right, were assembled inside a clean room at the Satellite Technology and Research Center. Over on the far left, you'll see our satellite bus consisting of the power, computer, comms modules, which were bought from off the shelf, and then our own in-house developed solar panel deployment system.
Solar panel.
And then over on the center, you see our in-house developed attitude determination and control system. Our ex-engineers, Aji, Johannes Horen, and Ren Hang, you probably find this very familiar. And finally, on the right, we put together the payload computer, which were in charge of doing the mission and also the RF communications. If Chen Ning, you're here, I'm quite sure you'll be finding this very familiar. Okay, so after getting all the modules integrated into their individual stacks, we then put them together to form up this 3U structure that we are all familiar with. Okay. Then following that, we did some wire harnessing according to a very stringent plan to ensure that all systems are interlinked and can work together. Okay, and then finally we close the solar panels and attach the antenna on to bring us to this final configuration. Yeah, so needless to say, on this day we were very happy after we put together everything, but the work is not done yet. We still have to qualify the satellite to ensure that it survives the launch environment. So we put it into a test pod, brought it over to TwoSuit PSB to do this vibration testing of the flight model to ensure that it will survive the launch environment. Other than vibrational testing, we also had to conduct end-to-end testing in which we test whether our antenna can communicate with the ground station. So here you see we brought our satellite and put it into a clean enough container in an attempt to communicate with this antenna down here. For those wondering, this is actually the antenna found on top S17, and it belongs to CRIPS, the Center for Remote Processing. Okay, so after we confirm all this, we then ship the satellite all the way to the launch site, and we finally received it at the launch site, where we did further integration with our colleagues from New Space India Limited, and one of which was to check that the satellite actually can fit into the deployer for it to be mounted onto the rocket. Subsequently, we made sure that the battery of the satellite is charged to the fullest possible. And then finally, this whole module is integrated onto the PSLV C56, which is currently awaiting launch now. Okay, so some things to take note later on when we watch the launch together. I would just like to share that PSLV is a 4-stage rocket known as the Polar Satellite Launch Vehicle. And the key moments to take note of are these few moments where after liftoff, the first stage was separate, second stage was separate, third stage was separate, and finally the fourth stage will bring the satellite to its desired orbit. More key information to know that after the satellite has reached the intended orbit, the main payload called SHAR will be separated first, followed by several other satellites, and we are fourth in the order of operations. Okay, so these are just some things for you guys to take note of and to keep a lookout for as we watch the video. And with that said, I have come to the end of my short sharing. I'm always open to take more questions, but I think everybody is just so excited about the launch now. So before we go over to that, I just want to say a huge thank you to all students and staff, past and present, for your unwavering support and contribution to this project. Because without your contribution, right, this would not have happened today. So from the bottom of my heart and on behalf of the entire Galassia-2 team, thank you very much. Back to you, King.
Thank you, Eugene. Okay, so I think the live telecast is on already, so I think we can switch over to IISRO YouTube. Give me a moment.
As we await the launch, let me tell the audience the major flight events that will be
Can I
taking
check if
place
everyone
in the
can see the
PSLV
video and hear
C-56
the voice? Okay, thank you.
DSR mission. This core-alone version of PSLV will inject 7 payloads in a mission lasting 23 minutes. At T0, the core S-139 ignites and the launch vehicle lifts off. By 109 seconds, the first stage would have completed its operation and separates from the ongoing launch vehicle. At this instant, the launch vehicle would have reached an altitude of 51 kilometers.
SATVCBPV open.
Soon afterwards, the second stage ignites and carries the rocket up to 169 kilometers altitude in its operational time of 152 seconds. During the operation of second stage, the launch vehicle clears the dense atmosphere, so the closed loop guidance is initiated and the payload fairing is separated. The third stage ignites soon after the separation of second stage. After operation of 120 seconds, the PS3 burns out but continues to coast along for another 200 seconds. By this instant, the altitude of the launch vehicle is 335 kilometers. The fourth stage, PS4, together with the payloads, continue to coast for another 263.3 seconds. After the burnout of the third stage, coast phase adds an altitude of 244 kilometers to the launch vehicle, while its relative velocity reduces a little. The fourth stage ignites at 14 minutes into the flight and operates for 272 seconds, during which the orbital conditions are achieved for the ignition of prime satellite TSR and 6 co-passenger satellites. The intended orbit is 6,914 kilometers circular orbit at 5 degrees inclination. The order of separation of other satellites is Neolon, orbit 12 Strider, followed by Glacier, then the Scoop 2, then Arcade, and finally Velox AM. Thereafter, the upper stage is maneuvered to a lower orbit.
-7 minutes.
अब हम उड़ान से 7 मिनट की दूरी पर हैं। ऑटोमेटिक लॉन्च सीक्वेंस जारी है। यह करीबन 14 मिनट चलता है और इस दौरान पायरो लाइन्स को सेफ से आर्म मोड में लाया जाता है तथा सभी संचार तंत्रों की आंतरिक जांच की जाती है। जैसा कि हमने बताया, पीएसएलवी प्रमोशन यान की कुल 57 उड़ानें हो चुकी हैं। यह 58वीं उड़ान होगी। पीएसएलवी की उसकी विश्वसनीयता के कारण इसरो का वर्क हॉर्स भी कहा जाता है। यह विश्वसनीयता सिर्फ प्रमोशन यान की नहीं बल्कि उस वैज्ञानिक, तकनीकी तथा व्यवस्था तंत्र की भी है जो हर बार इस मिशन को सफल करने में सक्षम है। पीएसएलवी रॉकेट की विश्वसनीयता गुणांक 97.6% है। हर एक सफलता के पश्चात इस गुणांक में वृद्धि होती रहती है।
External power is withdrawn, vehicle is fully in battery power.
पीएसएलवी न सिर्फ विश्वसनीय है, यह बहुमुखी भी है। प्रथम चरण के प्रणोदानुसार पीएसएलवी 4 मुख्य संरूपण में है: पीएसएलवी एक्सएल, क्यूएल, डीएल तथा सीए, जिसमें क्रमानुसार 6, 4, 2 और 0 स्टेप ऑन मोटर्स संलग्न रहते हैं। वर्तमान प्रमोशन यान पीएसएलवी C56 सीए कोर अलोन संरूपण वाला यान है।
We are close to 5 minutes from the launch.
MC confirms.
As a matter of fact, the uppermost stage of the rocket usually goes into the same orbit as the satellite the mission injects. The fuel left unused in the stage is vented and the stage is passivated. Passivation is a process of removing stored energy from space vehicle to reduce the risk of high energy release, such as explosions or fragmentations. However, the spent stage is an orbital debris itself. The orbital lifetime of the debris is very long in certain orbits. As a responsible space agency, ISRO is carrying out a change in the orbit of fourth stage after the accomplishment of mission. From 536 kilometers altitude, the fourth stage, PS4, will be brought down to about 300 kilometers altitude by firing the orbit change thrusters twice. First firing is scheduled 45 minutes into the flight, and second firing is scheduled 90 minutes into the flight. The re-entry into Earth's atmosphere from 300 kilometers altitude is likely to be in the order of weeks or a month. Though the burns of OCT will be tracked by ISRO's ground stations, the live transmission will not be available for the viewers.
On-board computers in flight mode.
सभी दर्शक प्रतीक्षा में इस प्रमोशन के। अब हम प्रमोशन से 3 मिनट 20 सेकंड की दूरी पर हैं। ऑटोमेटिक लॉन्च सीक्वेंस शुरू होने के पश्चात रॉकेट पूर्णतः स्वचालित होकर अपना आंतरिक जांच जारी रखता है तथा T0 पर या T-0.3 सेकंड्स पर सर्वप्रथम RCT का प्रज्वलन हम देखेंगे और तत्पश्चात T0 पर कोर बूस्टर S139 सॉलिड बूस्टर का प्रज्वलन शुरू होगा।
We are 2.5 minutes from the scheduled launch time, and the eagerness building up in the control center here.
जैसा कि आपको बताया गया, इस प्रमोशन मिशन में सभी 7 उपग्रहों के प्रमोशन के पश्चात PSLV C56 के चतुर्थ चरण को उसमें लगे ऑर्बिट करेक्शन ऑर्बिट चेंज थ्रस्टर्स को प्रज्वलित कर उसे 536 किलोमीटर्स की कक्षा से 300 किलोमीटर की कक्षा वृत्ताकार कक्षा में 2 चरणों में लाया जाएगा। यह प्रयोग भावी मिशन के डी ऑर्बिट सीक्वेंस के तकनीक प्रदर्शन के रूप में किया जा रहा है। ऑटोमेटिक लॉन्च सीक्वेंस सुचारू रूप से जारी है। सभी गतिविधियां सामान्य संतोषजनक तरीके से पूर्ण हो रही हैं। अब हम प्रमोशन से 1 मिनट की दूरी पर हैं।
-1 minute. -55 seconds.
All SHARs around.
यान पूरी तरह स्वचालित है।
Sequences around.
इसमें ऑनबोर्ड कंप्यूटर आंतरिक जांच द्वारा सभी गतिविधियां निश्चित कर रहे हैं और T0 पर खुद ही S139 बूस्टर के प्रज्वलन का कमांड इशू करेगा।
-30 seconds.
Real time program set.
-25 seconds.
PS2 VSPP open.
-20 seconds. -15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 0 plus 5 seconds.
Lift off normal. P1 tracking.
And we have a lift-off. The PSLV C56 first stage burning bright and the thrust is reported to be normal.
जी हाँ, अभी आपने देखा PSLV C56 प्रमोशन यान का सफलतापूर्ण उत्थापन प्रथम प्रमोशन मंच से और प्रथम चरण का निष्पादन पूरी तरह सामान्य है। यह करीबन 110 सेकंड तक चलेगा। इस दौरान यह 4800 किलो न्यूटन का प्रणोद उत्पन्न कर रहा है।
Normal thrust of PS1 stage 4,800 kilonewtons. The stage is 20 meters long and 2.8 meters in diameter.
इस दौरान रॉकेट अपने अधिकतम गतिक दाब से गुजर रहा होता है। यह क्षेत्र काफी कठिन होता है एक रॉकेट के लिए, लेकिन इसमें SITVC और RCT की मदद से रॉकेट को अपनी दिशा बनाए रखनी होती है और वर्तमान में सभी तंत्र सामान्य रूप से काम कर रहे हैं और प्रथम चरण का प्रणोद जारी है।
Presently, the launch vehicle trajectory is being tracked by SHAR stations. Operational duration for PS1 is 109 seconds.
Stage separated, second stage engine started, closed loop guidance initiated.
Plus 2 minutes.
प्रथम चरण के कार्यकाल के पश्चात उसे पृथक कर दिया गया है तथा द्वितीय चरण जो कि तरल नोदक वाला विकास इंजन वाला चरण है, इसका प्रज्वलन शुरू हो चुका है।
We are 2.5 minutes into flight and the rocket is at an altitude of 76 kilometers. The second stage has commenced its operation. It's a liquid stage that has 41 tons of propellant loading. Fuel is SDSC and oxidizer N2O4.
द्वितीय चरण वर्तमान में प्रणोद उत्पन्न करता हुआ इस चरण के दौरान ही पेलोड फेयरिंग यानी ऊष्मा कवच को यान से पृथक कर दिया जाएगा तथा यान क्लोज लूप गाइडेंस के अंतर्गत चला जाएगा।
The legendary Vikas engine powers this stage and generates a maximum thrust of 800 kilonewtons. PS2 stage is 12.8 meters long and 2.8 meters in diameter. In the meantime, the rocket clears the dense atmosphere. It no longer needs to be steered to reduce aerodynamic loads and it can now be guided based on final destination with respect to its current position, marking the beginning of closed loop guidance. No dense atmosphere around, no need to carry the extra weight to protect the satellite. Payload fairing have been jettisoned.
ऊष्मा कवच को यान से पृथक कर दिया गया है तथा यान क्लोज लूप गाइडेंस के अंतर्गत है, जिसमें सेंसर्स की मदद से वर्तमान की स्थिति का पता लगाकर रॉकेट अपनी अभिवृत्ति नियंत्रण तथा उद्देश्य कक्षा की ओर जाता है। PSLV का द्वितीय चरण का निष्पादन जारी है।
Second stage performance normal.
यह लगभग 150 सेकंड तक प्रज्वलित रहकर 800 किलो न्यूटन का प्रणोद उत्पन्न करता है।
Second stage separated, third stage ignited.
जहाँ इसकी पुष्टि हो चुकी है कि द्वितीय चरण अपना प्रज्वलन काल समाप्त कर पृथक हो चुका है तथा तृतीय चरण का प्रज्वलन शुरू हो चुका है।
Performance normal.
तृतीय चरण HPS-3 के नाम से हम जानते हैं। यह इस चरण में 7.6 टन का प्रणोदक होता है और यह 240 किलो न्यूटन का प्रणोद उत्पन्न करता है।
The third stage has commenced its operation. It is a solid
Plus
propellant
5 minutes.
stage. Current altitude 180 kilometers, ground range around 480 kilometers. Maximum thrust that the stage develops is 250 kilonewtons. It has 7.65 tons propellant loading.
जी हाँ, यह ठोस नोदक पर आधारित चरण है जिसे उच्च निष्पादन के लिए बनाया गया है। इस चरण का कार्यकाल लगभग 120 सेकंड का होगा।
Third stage performance normal.
इस चरण के अंत तक यान 220 किलोमीटर की ऊंचाई तथा सापेक्ष गति 7.25 किलोमीटर प्रति सेकंड की प्राप्त कर चुका होगा।
Plus 6 minutes.
SHAR station continues to track. Port Blair station has just started to acquire the rocket's position.
Third stage action completed.
तृतीय चरण का निष्पादन समाप्त हो चुका है। अब PS3 स्टेज यानी तृतीय चरण और चतुर्थ चरण संयुक्त रूप से यान के साथ आगे बढ़ रहे हैं। इसे हम PS3 PS4 कोस्टिंग फेज बोलते हैं।
The third stage of PSLV has completed its operation, but it will coast along with the ongoing rocket.
Vehicle
In the meantime,
performance normal.
no thrust is being imparted
Plus
by the
7 minutes.
rocket, but the rocket is being steered. SHAR and Port Blair stations continue to track. The combined coast phase lasts for 200 seconds or until 9 minutes 42 seconds into flight. As the rocket is not thrusting, its relative velocity reduces. Meanwhile, it gains altitude.
PS3 PS4 स्टेज का कोस्टिंग फेज जारी है। इसमें बिना किसी प्रज्वलन के यान प्राप्त संवेग से 115 किलोमीटर की अतिरिक्त ऊंचाई प्राप्त कर लेगा। यान की गति में कुछ गिरावट आएगी, फिर यान से तृतीय चरण को पृथक कर दिया जाएगा। तृतीय चरण के पृथकन के पश्चात
Plus
भी
8 minutes.
चतुर्थ चरण का कोस्टिंग फेज जारी रहेगा। यह 263 सेकंड तक जारी रहेगा।
Vehicle performance normal.
अब तक सभी तंत्र सामान्य प्रदर्शन करते हुए सापेक्ष गति 7.17 किलोमीटर प्रति सेकंड, ऊंचाई 287 किलोमीटर।
To put the coasting phase in perspective for the viewers, the first stage carried the rocket till 51 kilometers. Second stage for another 118 kilometers. Third stage, next 51 kilometers, and combined coasting phase will add 118 kilometers altitude. Even after the separation of PS3, which is the next flight event, coasting of fourth stage and payloads continue for
Vehicle
263
performance
seconds.
normal.
Brunei Station 2 has started to track.
यह मिशन पूर्वी दिशा का मिशन है। इसमें भू स्थित ग्राउंड स्टेशन शार, पोर्ट ब्लेयर, ब्रूने और बयाक हम तक आंकड़े उपलब्ध करा रहे हैं।
Third stage separated.
अभी अभी पुष्टि की गई, तृतीय चरण को सफलतापूर्वक यान से पृथक कर दिया गया है। तथा चतुर्थ चरण का कोस्टिंग फेज जारी है।
Plus 10 minutes.
Vehicle performance normal.
यान सामान्य निष्पादन करते हुए अपने अपेक्षित पथ का अनुकरण करता हुआ जा रहा है। यान की गति 7.09 किलोमीटर प्रति सेकंड तथा ऊंचाई 354 किलोमीटर।
Current altitude 359 kilometers.
DSR उपग्रह सिंगापुर सरकार द्वारा ST इंजीनियरिंग द्वारा संयुक्त रूप से निर्मित किया गया है। इस मिशन से पहले सिंगापुर के लिए PSLV C-55 द्वारा TLS-2 का सफल प्रक्षेपण किया जा चुका है। DSR एक सिंथेटिक अपर्चर रडार लिए हुए है जो कि किसी भी मौसम और किसी भी समय 1 मीटर के रिजोल्यूशन के साथ भूप्रेक्षण में सक्षम होगा। यह सैटेलाइट इमेज सिंगापुर सरकार के विभिन्न विभागों के लिए सहायक होगा। ST इंजीनियरिंग भी इसमें वाणिज्यिक ग्राहकों के लिए इससे मल्टी मॉडल और उच्च प्रतिक्रियाशीलता इमेजरी का प्रयोग कर अपने उपभोक्ताओं को प्रदान करेगा।
Vehicle performance normal.
वर्तमान में चतुर्थ फेज का कोस्टिंग फेज जारी है।
Plus 12 minutes.
PSLV C-56 कुल 7 निर्धार लिए हुए है। इसमें मुख्य उपग्रह सिंगापुर के DSR भूपेक्षण उपग्रह है। अन्य हैं 23.6 kg के आर्केड, 23 kg का वेलॉक्स AM और 13 kg के ऑर्बिटल स्ट्राइडर। अन्य 3 नैनो सैटेलाइट्स जिनका भार 10 kg से कम है, यह गैलेशिया-2, न्यूलियन नामक नितभार हैं। इन सभी सहयात्री उपग्रहों को निम्न भू कक्षा में स्थापित किया जाना है।
Fourth stage and the payloads currently coasting. Current altitude is 432
Plus
kilometers.
13 minutes.
Vehicle performance normal.
कोस्टिंग फेज के दौरान चतुर्थ चरण में लगे हुए थ्रस्टर्स की मदद से पिच या रोल कंट्रोल किया जाता है।
The prime satellite for the mission, DSR, is developed under a partnership between Defence Science and Technology Agency of Government of Singapore and ST Engineering. Once deployed and operational, it will be used to support the satellite imagery requirements of various agencies within the Government of Singapore. ST Engineering will use it for multimodal and high responsiveness imagery and geospatial services for their customers. DSR carries a synthetic aperture radar
Plus
payload
14 minutes.
developed by Israel Aerospace Industries. This satellite can provide all-weather day and night
Fourth
coverage.
stage engine started.
चतुर्थ चरण का प्रज्वलन शुरू हो चुका है। यह चतुर्थ चरण अंतिम चरण है PSLV का, जो मुख्य उपग्रह और सभी नेतभारों को उनकी उद्दिष्ट कक्षा में लेकर जाएगा तथा अंतक्षेपित
Fourth
करेगा।
stage performance normal.
Fourth stage has commenced its operation. Twin engine based pressure fed stage, developing a thrust of 7.4 kilonewtons.
वर्तमान में गति 6.94 किलोमीटर प्रति सेकंड तथा ऊंचाई 481 किलोमीटर। सर्वप्रथम DSR मुख्य उपग्रह का अंतक्षेपण किया जाएगा। यह 536 किलोमीटर की वृत्ताकार कक्षा में होगा।
The fourth stage is also provided with reaction control system thrusters for attitude control, and orbit change thrusters will fire post-mission to reduce altitude of the spent stage to aid in early re-entry. Speaking about this payloads taking ride in this mission, the first satellite to be separated is DSR. This satellite can provide all-weather day and night coverage and capable of imaging at 1 meter resolution at full polarimetry. It weighs 352 kilograms. The second satellite, New Leon, is an acronym for New Space LoRaWAN Internet of Things Network. It's a 3U nanosatellite developed by New Space. It is a seed satellite for a LEO equatorial constellation providing continuous LoRaWAN IoT services. The third satellite, Orb 12 Strider, will carry the world's first multimodal all-electric propulsion engine featuring subsystems from Singapore-based ELINA, Orbital Astronautics and Aurora Propulsion Technologies.
ऑर्ब 12 स्ट्राइडर, इसमें यह 13 kg का उपग्रह है जो एक स्मॉल सैटेलाइट है। इस उपग्रह को भावी पीढ़ी के प्रोपल्शन सिस्टम का तकनीकी प्रदर्शन के रूप में प्रमोशन किया जा रहा है। इसमें पहली बार मल्टीमोडल ऑल इलेक्ट्रिक प्रोपल्शन इंजन का प्रयोग किया जा रहा है और इसमें मल्टी स्टेज इग्निशन, कॉम्पैक्ट हॉल थ्रस्टर्स और आर्म रेजिस्टर जेट्स भी लगे हुए हैं।
Fourth satellite is Galassia-2, is an educational 3U nanosatellite by National University of Singapore. Its main mission is to perform an inter-satellite link with Telios-1.
Galassia-2 एक 3U साइज का एजुकेशनल नैनो सैटेलाइट है जिसे नेशनल यूनिवर्सिटी ऑफ सिंगापुर द्वारा निर्मित किया गया है। इस उपग्रह का प्रमोशन पूर्व में भेजे गए टेलियोस-1 से अंतर उपग्रहीय संचार पथ का निर्माण करना है। यह अंतरिक्ष अनुप्रयोगों के लिए बहु स्पेक्ट्रमी इमेज लेने में भी सक्षम है। वर्तमान में चतुर्थ चरण प्रणोद उत्पन्न कर यान को उद्दिष्ट कक्षा की ओर ले जा रहा है। कुछ ही क्षणों में उपग्रह के उद्दिष्ट कक्षा की स्थितियां प्राप्त होते ही DSSR उपग्रह को अंतक्षेपित किया जाएगा।
The next satellites are Scoop-2, Arcade and Velox AM. Scoop-2 is a 3U CubeSat designed and developed by a student team of Satellite Research Center, Nanyang Technological University, Singapore. Arcade is a 27U microsatellite.
Satellite injection conditions are achieved.
उपग्रह के अंतक्षेपण की स्थितियां प्राप्त की जा चुकी हैं। अब कुछ ही क्षणों में DSR उपग्रह जो कि मुख्य उपग्रह है इसका अंतक्षेपण किया जाएगा। उद्दिष्ट कक्षा है 536 किलोमीटर। सात 7.1 किलोमीटर प्रति सेकंड।
DSR satellite separated.
और यह हर्ष का पल यहाँ पर इस मिशन के मुख्य उपग्रह DSR को अंतक्षेपित कर दिया गया है और इसके तुरंत बाद ही न्यू लियोन भी इस यान से पृथक हो चुका है और अपनी कक्षा में स्थापित किया जा चुका है।
The prime satellite for PSLV C56, that is DSR, has been placed in its intended orbit. Thereafter, the second satellite newly on also has been separated.
इस घटनाक्रम में अगला है ऑर्ब 12 स्ट्राइडर उपग्रह का अंतक्षेपण.
5 more injection events awaited. Next in line is Orb 12 Strider.
12 Strider satellite separated.
ऑर्ब 12 स्ट्राइडर उपग्रह को भी अंतक्षेपित कर दिया गया है उद्दिष्ट कक्षा में.
We have a confirmation of the separation of Orb 12 Strider, and Galassia-2 satellite also has been separated.
ऑर्ब 12 स्ट्राइडर के पश्चात गैलेशिया-2 को भी यान से पृथक कर उद्दिष्ट कक्षा में स्थापित कर दिया गया है. और इस घटनाक्रम में अगला है स्कूप 2 का सेपरेशन.
Two satellites separated.
यहाँ इसकी पुष्टि कर दी गई है. स्कूप 2 भी अपनी उद्दिष्ट कक्षा में स्थापित कर दिया गया है.
Scoop 2 satellite has also been separated. It has been confirmed. Two more injection events to go. Arcade and Velox AM.
यान पूरी तरह अपेक्षित पथ का अनुकरण करता है और अब तक सभी गतिविधियां सामान्य हैं. इस घटनाक्रम में अगला आर्केड तथा वेलॉक्स एएम का सेपरेशन हम देखेंगे.
Satellite separated.
Arcade satellite has been separated.
जी हाँ, इसकी पुष्टि कर दी गई है. आर्केड को भी उनकी उद्दिष्ट कक्षा में स्थापित कर दिया गया है. अब अंतिम उपग्रह वेलॉक्स एएम.
Arcade carries iodine-based solid propellant propulsion module based on the Hall effect thruster for orbit maintenance during the low altitude mission. It is developed by NTU and in collaboration with Inspire Consortium. Velox AM, the 7th satellite, is a microsatellite weighing 23 kilograms for technology demonstration of
AM satellite separated.
और वेलॉक्स एएम को भी सफलतापूर्वक उद्दिष्ट कक्षा में स्थापित कर दिया गया.
Satellites are separated. PSLV C56 DSR mission accomplished. Handing over to mission director.
और इन सभी 7 उपग्रहों के
has injected DSR primary satellite and 6 co-passenger satellites into their desired orbit. PSLV C56 DSR mission is fully accomplished.
Here we have a successful mission announcement that PSLV C56 DSR mission has been accomplished. As we take leave from you, please continue to stay with us for the address by Chairman ISRO Secretary DOS, Shri S. Somnath, and the mission executives.
सभी 7 उपग्रहों को उनके उद्दिष्ट कक्षा में अंतक्षेपण के
Hello
पश्चात
everyone.
यह PSLV
So
C56
Galassia-2 has been
मिशन पूरा
successfully
होता है.
deployed. Okay, so based on our information, I
से आगे
think
लेते हैं.
Galassia-2 will pass over Singapore at around 10:46 a.m. Okay, so by then Eugene and his group will be trying to establish connection with Galassia-2, and then we'll update everyone via the Telegram. Okay, so please sign up for our Telegram group if you have yet to do so. Yep. So by that, I think we can conclude our launch event. Okay, so we'd like to thank everyone for your attendance this morning. Okay, so if you would like to watch the telecast again, you can go to the ISRO. I'll stop share first. Okay.
7 satellites.
Right. So
successfully placed in the right orbit.
This is a QR code for you to join our Telegram group
This
so
is
they
the
can
mission
get update on
of
our
the PSLV for
Galassia-2
NSIL.
progress. Okay.
And I want to congratulate the
So
customers.
if you want to
Sponsored by
continue
Government
to
of
watch
Singapore
the telecast,
for
you can
having
go
this
to
mission on board
ISRO
PSLV
YouTube channel.
and
Okay.
their continued faith in our PSLV
So
for
once again,
deploying the
thank you everyone
spacecrafts
for
from
joining
Singapore.
us.
And Keng, maybe you can put the link to the YouTube channel on the chat, so it's
Okay,
easier
sure.
for people to.
All right.
And then we have also added the
onboard
a
orbit
link to
mission.
the Telegram in the
And
chat,
very
so it'll be
perfect
easier
orbit
for
at this time that we
everyone
have
to
got.
join.
All right.
Thanks, Losha. Thanks, Jayang.
Hey, thanks everyone.
Oh, thanks, Darren.
Thank you.
Thank you. Darren just shared on the chat. Yeah. Thanks. Bye.
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 Hey, bye.
Bye, everyone. Nice job.
Bye.
Great. Congratulations to all.
Bye, Pablo.
Hi, Losha. We should catch up.
Bye. Yes. See you.
Bye-bye.
Thanks, Losha.
Bye. Yeah. Thank you, everyone.
Thanks.
Yeah, King, thanks so much for organizing the event. Kok Zui. Thanks also.
Thank you everyone.